Biomimicry is a truly fascinating approach to innovation. It seeks sustainable solutions by looking at nature's time-tested patterns and strategies. The core idea is simple yet profound. Nature has already solved many challenges we humans grapple with today. Organisms and ecosystems have evolved over billions of years. They have found efficient ways to live, adapt, and thrive. The importance of biomimicry is growing rapidly, especially in fields like architecture. We are realizing that nature is the best teacher. It offers a treasure trove of inspiration for designing a better world for all of us. In architecture, biomimicry means designing buildings and structures inspired by the natural world. Architects are increasingly looking to nature's forms, processes, and entire ecosystems for guidance. This is not just about making buildings look like plants or animals. It is about understanding the principles that make natural systems so successful. Imagine buildings that can regulate their own temperature like a living skin, or structures that can gather water like a desert beetle. This approach aims to create buildings that are more efficient, resilient, and harmonious with their surroundings. It is a very smart way to build. One of the core principles of biomimicry is nature as model. This principle involves studying nature's designs and processes. We then use them as a direct inspiration for our own creations. Architects might study how a bird's bone structure achieves strength with minimal material. They might then apply this understanding to create lightweight yet strong building components. Or they could observe how a lotus leaf repels water and dirt. This could inspire self-cleaning building facades. This direct emulation of nature's blueprints leads to truly innovative and effective solutions. It is like having a master designer showing us the way. The other crucial principles are nature as measure and nature as mentor. Nature as measure uses ecological standards to judge the sustainability of our innovations. Are our designs truly energy efficient? Do they minimize waste? Do they enhance the local environment? Or do they cause harm? Nature provides the benchmark for true sustainability. Nature as mentor involves a fundamental shift in our thinking. We must see nature not merely as a resource to be exploited. Instead, we should view it as a wise teacher. It guides us towards more responsible and life-friendly ways of designing and living on this beautiful planet. This perspective is key. Many pioneering architects across the globe are now embracing biomimicry. Their projects serve as wonderful examples of how nature's genius can be translated into the built environment. These buildings are not just theoretical concepts. They are tangible realities, showcasing the practical benefits of this design philosophy. They stand as powerful testaments to what can be achieved when we learn from nature. These structures are inspiring a new wave of design thinking. They demonstrate that sustainable and beautiful architecture is indeed possible. We can see the positive impact with our own eyes. This is truly encouraging for the future. One of Africa's most famous examples is the Eastgate Centre in Harare, Zimbabwe. This remarkable building was designed by architect Mick Pierce. He took inspiration from the self-cooling mounds built by termites in the African savanna. Termites maintain a nearly constant temperature inside their mounds despite extreme external fluctuations. The Eastgate Centre mimics this passive ventilation strategy. It uses a series of chimneys and vents to draw in cool night air. This air is then circulated throughout the day, significantly reducing the need for conventional air conditioning. This design saves a lot of energy. Another iconic example is 30 St Mary Axe in London, widely known as the Gherkin, designed by Norman Foster and his team. Its unique form is not just for aesthetics. The building's aerodynamic shape helps to reduce wind loads on the structure. Its ventilation system is inspired by marine organisms like sea sponges and sea anemones. These creatures rely on natural currents for respiration and nutrient intake. Similarly, the Gherkin uses a system of light wells and a spiraling design. This promotes natural ventilation, reducing energy consumption for cooling and lighting by a large amount. It is a true landmark. These biomimetic designs offer substantial gains in sustainability. Energy efficiency is a major benefit, as seen in the Eastgate Centre and the Gherkin. By mimicking nature's strategies for climate control and airflow, these buildings drastically cut down on energy use. This results in lower operational costs and reduced carbon emissions. Furthermore, biomimicry often leads to material optimization. Nature builds intelligently using only the necessary amount of material. Architects can learn from this to create structures that are both lighter and stronger, thereby reducing material waste and environmental impact. This is good for business and for our Earth. Beyond energy and materials, biomimicry also offers clever solutions for water management and waste reduction. In nature, water is a precious resource, meticulously collected, stored, and used. Buildings inspired by desert plants, for example, can incorporate highly efficient rainwater harvesting systems. They can also treat and recycle grey water, mimicking the closed-loop systems found in natural ecosystems. When it comes to waste, nature operates on a waste equals food principle. Biomimetic design encourages architects to think about the entire life cycle of materials. This leads to buildings that can be easily disassembled and their components reused or recycled, minimizing landfill burden. The relevance of biomimicry becomes even more apparent when we consider global challenges like climate change. The construction and operation of buildings account for a significant portion of global energy consumption and greenhouse gas emissions. This is a major contributor to the climate crisis we're facing. Biomimicry provides a powerful pathway to mitigate this impact. By designing buildings that work in harmony with natural systems, we can drastically reduce their carbon footprint. Passive cooling and heating strategies, use of renewable energy, and sustainable material choices are all inspired by nature's efficiency. This is an urgent necessity for our planet's health. Furthermore, biomimicry fosters resilience in our built environment. Natural systems have evolved over millennia to withstand and adapt to various environmental stresses. They are inherently resilient. As climate change leads to more frequent and intense extreme weather events, our buildings need to be more robust. Architects can learn from how trees withstand strong winds or how coastal ecosystems manage storm surges. This knowledge can be translated into buildings that are better equipped to handle floods, hurricanes, and heat waves. This ensures the safety of occupants and the longevity of the structures themselves. Nature shows us how to endure. Ultimately, the vision of biomimicry extends beyond individual buildings. It encompasses the creation of entire cities and communities that function like healthy ecosystems. Imagine urban environments that actively clean their air and water. Imagine cities that generate their own renewable energy and manage resources in a circular fashion. This holistic, systems thinking approach is what biomimicry encourages. It is about fostering a symbiotic relationship between human settlements and the natural world. This is crucial if we are to build a truly sustainable and thriving future for generations to come. We must think big. For architects keen to integrate biomimicry into their practice, the journey begins with curiosity and learning. It involves developing a deeper understanding of biology and ecological principles. Collaboration is also very important. Architects can team up with biologists, ecologists, and other scientists to gain insights into nature's solutions. Thankfully, there are now many resources available. These include extensive databases like asknature.org, which catalog biological strategies. Attending workshops and pursuing specialized courses can also equip architects with the necessary tools and methodologies. This journey of discovery is immensely rewarding for any designer. A fundamental aspect of adopting biomimicry is dedicated observation and rigorous research. Architects need to spend time in nature, actively observing how organisms function and how ecosystems operate. The key question to ask is, how does nature solve this particular design challenge? This deep, patient observation is the bedrock of biomimicry. It is not merely about mimicking superficial forms. It is about understanding the underlying principles and functions that make natural design so effective. Careful study of specific organisms or ecosystems can unlock a wealth of innovative ideas. Nature has done the research for us. The future potential of nature-inspired designs is truly boundless and very exciting. We are only just scratching the surface of what is possible. Imagine buildings that can self-repair, like biological tissues. Picture structures that can actively sequester carbon dioxide from the atmosphere, like forests do. We could see facades that adapt to changing light conditions, similar to a chameleon's skin. New bio-inspired materials are constantly being developed. These materials promise to be stronger, lighter, more sustainable, and even biodegradable. The architecture of the future could be far more dynamic and integrated with the living world. In conclusion, biomimicry offers a transformative pathway for architecture. It encourages us to look to nature, our wisest mentor, for inspiration and guidance. By embracing its principles, architects and designers can create buildings and cities that are not only innovative and aesthetically pleasing. They can also be profoundly sustainable and restorative. This approach provides genuine hope for addressing some of the most pressing environmental and social challenges of our time. Let us all strive to learn from life's genius. Let us design a built environment that nurtures life and helps our planet thrive. This is a noble goal.